Hello everyone, welcome to this segment where we're going to understand what is bubble sort. So bubble sort is a simple in-place sorting algorithm. Here, in each iterations, we are comparing the elements inside the list and based upon the requirement to sort the array in ascending or descending order, we are swapping the elements. And after all the iterations are over, we are getting finally our desired output as sorted list. So let's understand this particular algorithm with an example. So here initially we have taken one list which is containing initially 5 elements and all are in unsorted order. So currently number of elements we have are 5, so we put as n equals to 5. And it should be properly understood, number of iterations always be going to be n minus 1, which is in this case is 4. We require total 4 iterations to completely sort this unsorted list to an sorted list. So let's see how the first iteration works. So here our main agenda here is to sort this particular list in ascending order. So to sort this particular list in ascending order, the elements we have to compare and accordingly we have to take the decisions. So here we in the first 2 elements we see 67 is coming before 22 and 22 is the smaller one. So we know that in ascending order the lower should come appear first, after that then the higher one from that element. So 67 is not in the correct place, 22 is also not in the correct place. So we need to just require a swapping. So we swap here. So once we swap we get this state here. 22 is now coming first and 67 is higher now. Now again we check the comparison with the next elements with the 19. So in 19 also if you can see here it is the lowest. Accordingly we do the swapping here as well, then followed by the other elements 50, then 8. Accordingly we do swap, and finally we get a state in which 67 is currently in the last location 67. And as you remember, if you actually remember what is with the sorted list of this particular initial list we have taken, it should be 8, it should be 8, 19, 22, 50 and 67. So as you can see in the final sorted list, we see that 67 is coming in the last location, and also after first iteration is over we see that 67 is coming in the last location. So means this segment is sorted, this segment is still unsorted. This is clear. So after first iteration we can clearly say that our one element from the last we have sorted and other element are still in unsorted order. So this is done, iteration 1 is complete here. Now we go to the iteration 2. In iteration 2, the state will be from here. So whatever state we have here, we will go directly to this location. Now we'll start the same journey from what we did in the first iteration. Compare the first initial two, based upon that we do swapping. So we swap it here, 19 came 22. Then 22 and 50, we don't require swapping because already they are in their own correct order. So again we go proceed with the next element 50 and 08. So we get that we required swapping, so we swap the value. After this particular last of this iteration 2, we see that this is sorted, and also in the if you compare with the sorted list 50 and 67, this is matching here. So means these are sorted now, these are unsorted now. We now need to sort this particular 3 elements in the next iteration. So in the next iteration this will be the state. We start with same comparison 19 and 22, and we see that 19 is in correct location, so we don't require any swap. We proceed further with 0, 8 and 22, and accordingly we do the swapping here, and finally we get 22 in its correct location. This is sorted now and this is unsorted. Now this will go in just here. Similarly we check whether swapping is happening or not. Swapping is required here, so we swap it, and once all this done we are finally getting our sorted. So whole elements are now sorted. So if you can see, in total 4 iterations we are able to achieve our goal, which is to sort this particular entire list which is initially in unsorted to sorted. So this is how a run or the dry run, it's on based on small examples. Now we'll see the algorithm implementation using Python code. So initially we have taken an array which containing these particular elements, total 5 elements we have, and we are passing to an definition we have created, but we didn't written anything inside it now, the logic. So we just passing this array to this particular function, and we'll implement now how to implement the bubble sort algorithm here. And once we are done with our calling here the bubble sort algorithm, we finally get our sorted array in this particular section which we are printing here. So let's see the bubble sort algorithm implementation here using Python. So before going to the first declaration, we should have the number required, or the number of elements should be required to us. So we have to write an n equals to len of arr. So this ensures that what is the length of the current elements, or the number of element inside the arr list, is going to be stored inside the n. Okay. Now, second thing is, what is number of iterations we required? So number of iterations required, I already mentioned as a formula n minus 1. So here we just put an for loop accordingly. For I in range starts with 0 and ends with n minus 1. That is the number of iterations we required. Okay. Now the second stuff is that in each iterations what we are actually doing it, we need to write it here. Okay. So in each iterations we are doing for j in range start from 0 and end it at n minus I minus 1. Now you may be thinking why we are added n minus I, because if you see in this particular example which I have written here, in this particular segment, if you see, this is the initial array or the list we have here. So in this list, if you see, once we have done the first iteration is over, we get 64 in its correct location. So once 64 is in correct location, in the further step, we are not actually taking 64 in the other processing for the P2 or the iteration 2, pass 2, we are not taking the iteration of 64 anymore. We are just focusing on the remaining elements because 64 is already in its correct location after the pass 1 or the first iterations. So if you see, we are reducing the size or the scope of the unsorted list in each iterations. Right? So this is pretty much clear from the implementation. So if we started with initially with 5 elements, in the next iteration we are only dealing with 4 elements, and the next iteration we are dealing with 3 elements. Accordingly we go to the 2 elements, 1 element, and finally we are done with sorted. So in each iterations we are reducing our size of the scope of checking or the comparison. So that's the what we have written I. So here if we see in the first iteration when I is done, so we still have n minus 1 iterations and it will work for entire array. So when I equals to 1, then in that scenario that will convert to total 4 elements. Similarly, it will keep on reducing as I is incrementing, and here the scope of or the j iteration will accordingly work, and it is depending on that one. So we have written that's why n minus I minus 1. Okay, now this is much clear with this that what we have to do, and but we have to write the code also to check or to compare. Suppose we want to sort this array in ascending order, we need to check whether that two adjacent elements are in correct order or not. So how we are doing, we do the simple comparison using if condition. If arr of j is greater than arr of j plus 1. If this is the situation we have, then please do swapping. Here we require swapping. So how we can do swapping? Simple algorithm to is using our Python shortcut. So if the adjacent values are in not correct order, we do swapping, and this swapping is performing here. So it is now clear from this. So now once we done with this algorithm, we are completed here with this implementation of bubble sort. So bubble sort actually does the same stuff. Like we are running the iterations over this particular array until we require all those iterations are over, we finally get our sorted array. Now let's run this particular mm, implementation which we did here and see how we are getting the desired output or not. So as you can see here, we are getting our final sorted array, which is the is in ascending order, which is from 12, 22, 25, 34, and 64. So this is how bubble sort works, and this is how we have implemented also using the Python code. Thank you.